Hello friends, once again I'm here with another clip on secant method, and secant method happens to be one of the methods that is used in numerical methods to get an approximate solution to nonlinear equations. So let's get started. So first of all, for us to write a simple script or a function for secant method, we need some arguments, of which the first one we are saying we want the function to provide our initial guess. We call it A. That's what, and then the second guess should be B. From there, we want the function to provide us with a certain number of iterations, and this providing the number of iterations works when we are considering the for loop. And then our last argument is what? The function under consideration. So from there, we want to now go ahead and write since we are using the for loop, we start for our I. Let's say we want our I starting from 1 to a certain n. We like to first end it, and we come here, we say, okay, let's say a certain p should be equal to a times our function times b minus b all divided by a b we need to close it first. Yeah, we then suppress it. Then we are saying, okay, the values that we have for a, first of all, our b should be assigned to a, and the value for p should be assigned to b. That's what line 10 is telling us. From then that is so simple. So from then we want to display the output at the end of the iteration. We say, okay, approximate like root num to string. So we use the num to string to change our value that we have obtained into what? A string. That's a number to string. That's what it basically means. Then we end it there. So that's pretty simple. So first of all, we supply the argument, we call the function, and from the function we write. This is the secant method to find the root, and the values of p that we have obtained. First of all, we say we assign our b to a, and the b's value that we have obtained here should be assigned to b for iterative purpose. So let's run this code and see how it works. First of all, we need to save it. Alright, so it's calling for our first guess, which is 0.45, 0.5, and we give a number of iteration to be 5, and our function, we call it, we want to create an anonymous function, so we start by an @ sign, and then we supply our x. We have x times, that's the function, exponential, so x minus 1, yeah. Okay, we have an issue, num to string. Okay, so when you come here, num to string, that's where we have the problem. So let's start all over again. 0.45, 0.5. We already have number of iterations, we say it's 5. We call the function. Okay, so it gives us the approximate root of 0.56714. That is the approximate root under the secant method. So now let's increase the number of iterations and see how it actually works. At this time around, we clear the whole screen. We can run the function here again, and it's telling our initial guess 0.5, 0.4. Okay, then number of iterations, we say we increase it to 10, and our function, we already have the function, so we just quickly call the function, and it's telling us what, not a number. Okay, so not a number, so that's one flaws under the for loop. We need to know the number of iterations that we have to perform in order to get the approximate root. So meaning we can't perform iteration more than 10. So we want to first look at another instance under which we want to convert the whole thing into a function from here.